10.6 radical equations and problem solving. So now we're going to use radicals and equations. So we're adding this part, right? Now it's going to be an equation, and we're going to have to solve for x. So there's ways to solve this one. There's instructions here. So when solving radical equations, the first thing you need to do is isolate one radical on one side of the equation. So that's the first thing you're going to need to think. How we need to isolate or leave one radical on one side and then everything else on the other. And then after that, after you isolate that radical, you're going to raise each side of the equation to a power equal to the index of that radical. Why? Because it's going to cancel the radical on one side. And then after that, you would solve for x. If not, you would repeat steps 1 and 2 in case you're left with another radical. So for example, this one is already, like, the radical is already on one side. So what you need to do is you need to raise both these parts of the equation to that index. So that index is 2. I'm going to put the 2 even though it's not there. So based on those steps, step 1 was already done for us. Step 2 would be to raise to the same power as the index. Why is that? Because that would cancel this, and you would end up with whatever's inside. And then 9 squared would be 81. Okay, after that, solve for x, so it's a simple equation now. 84. So this would be, it's 41. So 41, 42. So 42. So that's the answer for that one. Sometimes you guys need to check just to see if it's true. I'm not gonna do it every time, but just if you guys want to check to see that answer is correct. So you're gonna put it in the original. So 42 minus 3 equals 9. So 2 times 42 will give you 84 minus 3. 84 minus 3 is 81. Square root of 81 is 9. So it checks. It's true. It checks. So that means that's the answer. Okay, example number 2. So the same thing, except step 1, remember step 1 would be isolate radical. In this case, it's not isolated because we have this part. So you're going to have to take this part to the other side. Like that, so that becomes 0. So you're left with negative 10x minus 1 equals negative 3x. So now, next step would be to raise to the power of the index, because we already isolated the radical on one side. So now you're going to raise. So this would cancel that, right? Because this has the same index, has the same power, cancels out, becomes a 1. So you're left with this one equals, now negative 3 squared would be positive 9, right? Because you're going to multiply negative 3 twice. So positive 9. And this would just be x squared, right? You guys should be good with this stuff. So now we need to bring, because if you guys notice, aside from this one didn't have a square, the x. This one does, so this one will become one of those quadratic equations. So negative 1 equals 9x squared plus 10x and then plus 1. So you're going to have 0 on one side. So 9x squared plus 10x plus 1. So here, this is a part where you're going to factor, remember that. So we're going to factor this. You can divide by anything. You're going to do the x. Let me do it over here. 9 times 1 is 9, and then the 10 here. So that would be 9 times, and that's positive. Everything's positive, so 9 times 1. 9 times 1 gives you 9. 9 plus 1 gives you 10. And then you divide by that leading coefficients. So this becomes 1 over 1, and that one just stays like that. So this is the x's, so 1x, 9x, plus 1 for this one, and plus 1 for this one. So this should be the factors. So here you're gonna, let me put it over here, I'm not gonna have enough space. Here you're gonna split them and equal them to 0 because we're gonna solve for those two x's. So this would have two answers. So minus 1, minus 1. So x equals negative 1, and then this one minus 1. So 9x equals negative 1, and then divide by 9. So x is equal to negative 1/9, and this is this. So these are two possible answers. You will need to check, and I can tell you they're both gonna be true when you check. So if you guys want to check, because sometimes you might get a false answer, a false result, and one of the answers won't be a valid one. But for this one, they both check. It's already checked previously. So those are the answers. Example 3. So remember, that's a cube now. So again, the same process. We need to isolate the radical. So we still have this to get rid of. I'm gonna use. So we need to get rid of that 5. That cancels. So you're left with this, and that would be negative 2. And then you're gonna raise to the index both sides. So that's gonna cancel. You're gonna end up with x plus 1, and negative 2 to the third power is negative 2 3 times. You multiply negative 2 3 times, that gives you negative 8. And I just solve for x. So minus 1 minus 1. So x is equal to negative 9. And if you check again, it does check. So that would be the solution. Number 4. So number 4 is the same thing, except now we have a binomial on this side. So I'm gonna start from this corner. Okay, this is long. So again, the radical is already isolated on one side, meaning this thing. So you're gonna raise to that index. That index, it's 2. So you're gonna raise to the second power the whole thing. So this will eliminate that radical. You're gonna end up with 4 minus x. And then on this side, you're gonna have to expand this. You're gonna have to FOIL. Then this is the easier, best way, because that. So 4 minus x. So x times x gives you x squared. Positive minus, so you're gonna get a minus 2x. Minus positive, so again minus 2x, right? 2 times x, and then negative, negative, positive 4. So 4 minus x equals x squared minus, so you are able to combine these two. They're like terms. So negative, negative, so you're combining the coefficients, they have the same letters, so negative 4x plus 4. And then we need to bring everything actually to the other side, because it's a quadratic. So remember, to solve quadratic, you need to leave put everything on one side, and then the other side should be a 0. So minus 4 4. Oh. So this cancels out, so you get negative x squared minus 4x. 4 positive minus 4, this cancels, so you're left with this. And then plus x. So that goes away. It becomes 0 now, so you had x squared negative 4x plus x will give you negative 3x. So now what? Can we factor this? Yes, we can factor an x from this side because they both have x. So we're going to have the x outside. So x squared over x would just be x. And this goes away, so minus 3. So now what happens? Since we have two different letters, we can split them. So one of the solutions, x equals 0, and the other one plus 3, so x equals 3. So I'm going to check this one because this is one of those examples where it doesn't check. So we're going to use that original. So let me use a different pen. So I'm going to check this one. So for minus, what's x? 0 is equal to 0 minus 2. 4 minus 0 is just 4, and then 0 minus 2 is negative 2. Square root of 4 is positive 2, and the other side is negative 2, so not false. This is false. So this is not a solution. Now let's check this one. So for minus, so we're using this one, 3. It's equal to 3 minus 2. So 4 minus 3 would be 1. 3 minus 2 would be 1. Square root of 1 is just 1. Equals 1, so that one's true. So this is a solution. And this one is not a solution. This would be the only solution. This is called extraneous. So I'm gonna put it here. This is extraneous solution. So the only solution is this one. This is extraneous, so we don't use it. So example, we're going fast. Example 5. There's 5, 6, and 7. Okay. Example 5. So for this one, they're giving you this. There's two radicals. So we're gonna have to send one radical to one side. I'm gonna send this radical to this side. So let me copy it here. And then at the end, I'm gonna use this one. Let me see if I want to show you that one first. Okay. Maybe I should show you 6 first, because that one's crazy. Let me show you 6. So here we're still using the Pythagorean theorem for example 5 and 6 and 7. So Pythagorean theorem, remember guys, a squared plus b squared equals c squared. AB are the legs, and then the c is the hypotenuse, and these are the lengths of the sides. And you put them here and you square them, and they should be equal. So here we have, and that only works with right triangle, right? Triangles with the 90-degree angle. 30. So this one needs a right triangle, 90 degrees. So opposite of the 90 degrees, it's a hypotenuse. And these two are the legs. This is leg, the legs. So we're gonna use again the Pythagorean theorem to solve for these ones, because it's find the length of the unknown leg. of the right triangle. So we don't know this leg, it's B. We know this leg, so we can say that we can substitute here. Right, 4 would be A, this is just B, and then that one would just be the C. And that one's the B. So that's the height. So A squared would be 4 squared plus B squared, we don't know that one, equals 10 squared. So 4 squared equals 16 plus B squared equals 100. Okay. So now we don't have any radicals here, but we still need to solve for the missing part. So we're going to send the negative 16 to the other side. So this would be 84. And then to solve for something like this, remember how we supposed to raise to the same index? This would be the opposite. We need to find the root of the same index that matches that exponent. So 2, right? So square root of that. So what happens here? It cancels this. This is just a skill that you guys need to have. When you have that power, you can raise to that same power, but as a root, and then you can cancel. Or if you have the root, you can raise to the same power of the index, and then you can cancel. So now you have square root of 84. So I know square root of 84 is not a perfect square root. Remember, the perfect square roots are 4, 9, 16, 25, 36, 49, 64, 81. So these are the perfect square roots. This gives you 2, 3, 4, 5, 6, 7, 8, and 9. Like that. So this one, can we split it so that we can simplify it further? Yes. And I forgot to mention something that's very, very important. When you go the opposite way, so when you square root to eliminate the power, that answer becomes a plus and a minus. Because there's a chance that to get that answer, we are gonna have a plus, a minus number might give you that answer or a plus 1. So here we're gonna split this one. So remember, when you do that, always plus minus, except for cube roots. Cube roots, it's different. So this one would be, so B is equal to plus minus. This can be breaking down into, I think, 4. 4 times 21. 4 times 21 gives me 84. And then we do the square root of 4. You guys know that's 2. So plus minus 2. 21 can do nothing about it anymore. It stays like that. Now, since we're dealing with length, so we're dealing length. Length has to be positive for this. So the only answer that we can use is the positive one. So B would be 2 square root of 21, the positive. The negative one, then we can't, because we can't have negative lengths. So that would be the answer. Let's see if I can do 7. Looks easy. I'm gonna skip 7. Let's try this one. This one looks hard, but I'm gonna try it anyways. So let me copy it over here. This is the last one. So what you need to do here, you need to isolate one radical. In this case, we have 2. So I'm just gonna take this one to the other side and I isolate this one because that one looks more complicated. I prefer to get rid of this instead of that. So So negative, so 3 minus square root of 2x. Okay, so now we're going to raise to that index. So 2, so we're going to raise to the second power, the whole thing. So what does that do? It cancels this one, so you're left with 2x plus 5 equals, and then this. This part we're going to have to FOIL. Like that. And I show you, we learned this previous lesson. So you're going to have to FOIL. Well, if you watch the video and did it. So this side stays the same. So 3 times 3 would be 9. 3 times that negative, so negative, positive, negative, negative. So it would be 3 square root of 2x. And then these times that would be negative again, right? Negative, positive. 3 times that would be 3 negative 2x. And then negative, negative would be positive. So I'm going to put this 2 inside, 2x squared, like that. So 9. So you are able to combine these two. They're the same, they have the same radical and the same index. So you combine the numbers outside. That would be negative 6 square root of 2x. This one, they have the same index and the same power, so they cancel, so you're left with 2x, whatever's inside, like that. And then, we still need to solve for, actually here, this is a case where we're going to bring everything to one side, because we have another radical. So we're going to have to do step 1 again. So negative 2x, negative 2x, and look, that cancels out, that cancels out. So you have 5 equals 9 minus 6 square root of 2x. So we still need to get rid of this one because we need to isolate this one. So negative 9, negative 9. So that would be negative 4 equals negative 6 square root of 2x. So from here, we can divide by that negative 1. So that negatives go away. And that negative goes away. So you're left with 4 equals 6 square root of 2x. And you could have divided over here if you wanted. You could have taken the 6. Or we can square root from here. So now the index tells you that you can square root both sides. And you could have done this on the bottom, it would have just worked the same. So this would be 16. 6 squared would just be 36. And this cancels out. So you're going to times 2x. Okay, so that's 16. 36 times 2 would be 72x. And then divide by 72. So x is equal to 16 over 72. And this can be simplified to 2 ninths. So that would be the answer, and it does check. Checks it's true. And that's it, guys, for today. Thank you.